So now we are going to the most important point. I think that to find the square root of a complex number. Why I think that? Because that question, it's not repeated in the past exam papers before. So no like that question in past exam papers. So if you get like this question in the exam, at least he will take 5 or 6 marks. So we have only one way to find the square root of the complex number, but maybe you get the question in different types. So maybe he asks you directly like that, find the square roots of 5 plus 12i, or directly just do that, find the square root of 5 plus 12i. That is the square root. So how to solve like that question? Complex numbers are often denoted by z, and we can refer to the real and the imaginary parts respectively using real z as x and imaginary z represented by y. So we consider that z is equal the square root of 5 plus 12i. And as we know, z often is equal x plus I y, real part and imaginary part. So to remove the square root, we just need to square both sides. So we just do that, square both sides, here and here. And as you know, z squared, it will be x plus I y all squared. And that squared cancel the square root. So the answer, it will be 5 plus 12i. I told you before in the previous hand, x plus I y squared always is equal x squared minus y squared as real part plus 2xyi. If that sign is negative, so that sign, it will be negative. And memorize that. So we know that always that expression, it will be the real part is x squared minus y squared. And the imaginary, according to that sign, it's a plus, it will be plus 2 times xyi. All of that is equal 5 plus 12i. It's important to note the two complex numbers are equal if and only if both the real and the imaginary parts are identical. Real equals and imaginary are equals. So we just state that from here. We equating real in both sides. On the left hand side, x squared minus y squared represent the real, and right hand side 5 represent the real. So we just equate real z in both sides. So I got x squared minus y squared, that is the real here. And opposite side, the real is equal to 5, so all of that is equal 5, and that is the first equation. And when we equate the imaginary part, the imaginary here represents the coefficient of I, and the imaginary here, it will be the coefficient of I. So we state that equate imaginary z in both sides. So we get 2xy is equal, the imaginary here, it will be positive 12, and that is the second equation. So we notice we have two simultaneous equations, both of them quadratic. We cannot use a calculator to solve that. We have only one way to solve that equation. And he did like that previously in grade 11. we have only one way to solve two quadratic simultaneously. So always to solve like that questions or like that equation, we start from the second one to state the variable of x or y, each of which. So always we choose y, so y here is equal. We divide 12 divided by 2x, 12 divided by 2x, we divide by the number with the y here. So 12 divided by 2 will be 6, so y equals 6 over x. We state y from the second equation. So we're going to substitute in first, sub n1. Why? To change that equation from x and y to be in only one variable, x or y. But here we have the value of y. It's equal 6 over x. So we just substitute y by its value in that equation. So it will be x squared minus, I have here y squared, but as you know y, here equals 6 over x. All of that is equal to 5. Now I have equation in only one variable, which is x. We just do that, x squared minus square distributed for division, so 6 squared, it will be 36 over x squared, all of that is equal to 5. So as you know, to remove any denominator, we just multiply through that denominator to remove. So to remove x squared here, we just multiply all terms by x squared. Multiply through x squared. Here I will multiply by x squared. Here I will multiply by x squared. Here I multiply by x squared. Why? To cancel that. So we get x squared times x squared, it will be x to the power 4 minus 36 equal, here 5 times x squared, it will be 5x squared. It's a quadratic equation because I have three terms, the power on the first one equal the power on the twice the power of a squared. So rearrange that equation, x to the power 4, we're shifting that to other side with the opposite sign, it will be minus 5x squared minus 36, all of that is equal to 0. Now you can use a calculator to state the final answer using mod 3 and insert the coefficient 1 equal negative 5 equal negative 36 to get the answer. But the answer here, it will be represented using the middle variable. Answer here is not x, it will be x squared. So I got to answer x squared and x squared. Or you can factorize normally like that. X to the power 4, it will be x squared times x squared. Two numbers has product 36 and the difference 5, I think 4 and 9 or 9 and 4. The last sign negative, so I have two different sign. The bigger factor take the sign of the middle, that, so the other it will be opposite. So using a mod 3 you will get that x squared equal positive 9 or x squared equal negative 4. So as you know, it's impossible to get a square root of any number equal negative. So that is rejected, not belongs to real number. So what about this? X squared equal 9, so x is equal root of 9, it gives us two possible values, positive or negative 3. But we need to state the values of y. So we just do that when x equal 3, when x equal negative 3. We substitute in the value of y here. Y equals 6 over x, so y equal 6 over 3, it will be equal to. Y equals 6 over negative 3, it will be negative 2. And as I said before, always the complex number denoted by z equal x plus I y. So the square root from this one, the value of x, it's a 3 plus the value of y it's 2, it will be I2, and here the value of x it's negative 3, and the value of y it's negative 2, so negative I2. So that represents the square roots of that question. So let's go to practice another question in different form. The old question to give us square root is the same. We have only one way. So maybe you got question like that. It's not tricky because the old question have the same style in the solution, but here I have different way to ask. He said given that a plus ib all squared equal 5 plus I12 by computing a and b, which are assumed to integers. So we just need to find the values of a and b. He didn't ask me to find the square root, but we noted that if a plus I times b all squared is equal 5 plus I12 as given. To remove that square, we just need to square root for both sides. So it will be a plus ib is equal square root of 5 plus I12. So it's the same question. He asking about the square root, not asking about a and b. So that means I can do that from here by squared both sides or find the answer here. That is squared. So directly it will be first squared minus second squared as real plus I times 2ab, because that sign is plus, so that always it will be plus. If it's negative, it will be negative. All of that is equal 5 plus I12. So here I have to equal complex numbers. So that means I refer to real equal real, and the imaginary are equal. So equating real, we get that a minus b squared is equal, the real here is 5, and that is the first equation, that a squared minus b squared. We equating that imaginary. So the imaginary in left hand side, it will be 2ab, it's equal. The imaginary here, it will be 12, and that's it, the second equation. So if you got a plus ib all squared or x plus iy all squared equal a complex number, that means you want to find the square roots. So you can do that from here. Because in the previous question, when you need to make a square root, we just squared both sides to remove the square root. So here it's given directly. Now, always we start from the second equation as we did before to find the value of a or b as you like. So I will try to find the value of b. It's equal 12 divided by coefficient of b, ab. So, sorry, 2a. So we just divided by 2, it will be 6. So b here equals 6 over a. So we substitute in the first equation, it will be a squared minus 6 over a all squared. All of that is equal to 5. Simplify, it will be a squared minus 36 over a squared. All of that minus 5. Shifting that to other side equal to 0. Multiply through a squared to remove the denominator. So I will multiply here by a squared, here a squared, here a squared, and here also a squared. Anything times 0, it will be 0. So it will be a to the power 4 minus, that cancelled, it will be 36, keep it at the end because it's the constant value. Then minus 5 times a squared, all of that is equal to 0. Solve the equation using mode 3 and complete like the previous one. And I think you will get like this question in the final. I hope to solve it.